Very welcome to all of you. I am your geography teacher Vandana Joshi and you are watching SST June. So students, as you know, in unit 4 climate, in which already we have started chapter 9, and in chapter 9 we have already studied about the solar radiation, in which we have studied the insolation process, and after that we have studied about the heat budget. So in heat budget we have seen the hotness and the cooling process of our atmosphere. Also we have studied about the terrestrial radiation. In our last video we have seen what is heat budget and how it is working. So students, in our today's video we will study about the procedure of heat budget and the topic temperature. Under the topic temperature, we will see the subtopics as the factors which are affecting or controlling to temperature distribution, and also we will see the distribution of temperature. At last of the chapter, we will see what is inversion of temperature. So let's start. What is the procedure of heat budget of the earth? Students, as already we discussed about the short wave solar radiation and the long wave earth radiation. So how we can calculate the heat budget of the earth with the help of solar radiation and the earth radiation? Let's have a look through a video which will be helpful to understand the topic, what is heat budget and how it can be calculated. So students, as you can see in this picture, let us assume the total heat received at the top of the atmosphere is around 100 units. Approximately 65 units are reflected back to the space even before reaching the Earth's surface, as you can see in this video. Of these, 6 units are reflected back from the top of clouds and 2 units from the snow and ice covered areas of the earth. The reflected amount of radiation is also known as the albedo of the earth, or we can say the reflection of the earth. The remaining 65 units are absorbed, 14 units within the atmosphere and 51 units by the earth's surface. The earth radiates back 51 units in the form of long wave terrestrial radiation. Here a question, what is long wave and what is short wave? Students, the waves which are reflected through the sun, these are coming in the short waves, and the rays or waves which are reflected by the terrestrial or the earth radiation, these are known as the long waves. And of these, 17 units are radiated to space directly, and the remaining 34 units are absorbed by the atmosphere. 48 units absorbed by the atmosphere, so 14 units from the insolation and 34 units from the terrestrial radiation are also radiated back into space. Thus, the total returning from Earth in 17 plus 48 is equal to 65 units, which were received from the sun. Thus, the balance of heat on the earth, that is called heat budget, and also it is helpful to maintain the temperature of our planet Earth. So students, under the topic heat budget, we have seen how the temperature is maintained by the different type of insolation and the radiation process. So the temperature, what is temperature? Which is maintained by the terrestrial radiation and the solar insolation. So let's see our next topic, which is the important topic of today's video, that is temperature. So students, first we will see what is temperature. Students, the temperature is the measurement in degree of how hot or cold a thing. Or we can say the radiation that is absorbed by the earth in the atmosphere and the heat changes under the reflection, which is controlled by various factors, is known as temperature. Temperature is reflected both vertically and horizontally, by which we feel cold or hot. The average global surface temperature is about 40 degree Celsius, but it could be varies due to few factors. So what are the factors which are affecting to the temperature at the different places? Because the temperature which is remaining in the atmosphere, it is same, but when it reaches to the earth's surface, it is having variation. And what are the reasons behind the temperature variation? So let's see what are the factors which are controlling or affecting to the temperature distribution in our earth. So students, the factors which are affecting to the distribution of temperature, these are latitude, altitude, distance from the sea area, and the air mass and the ocean currents. Few more factors are there which are known as the cloud cover and nature of the surface, which we can calculate it as our local factors. So we will see one by one these factors. So first of all, we will see how the latitudes is affecting to the distribution of the temperature. The latitudinal location of a place has a close influence on insolation, which determines the temperature. In general, the lower the latitude of a place, the more the solar energy it receives annually. The effect of latitude on seasonal variation is also significant. For example, more solar energy is received at the poles at summer solstice than at the equator. Thus, the latitude and time of year have a close bearing on the horizontal distribution of temperature. Now let's see what is the effect of altitude over the distribution of temperature. In general, in the troposphere, temperature decreases with increasing altitude above Earth's surface. The normal lapse rate of temperature change with altitude is 6.4 degree Celsius per 1000 meter, or we can say 3.5 degree Fahrenheit per 100 feet. Thus, throughout the world, mountains areas experience low temperature. The third factor is distance from the sea level. The location of a place in relation to sea or ocean and interior of a continent also controls the distributional pattern of temperature. The physical nature of the substances themselves, as rock, soil, and water, is the reason for the land-water heating differences. The coastal towns and cities have more uniform temperatures throughout the year, as they receive marine air from the prevailing winds. These places remain cooler in summer and warmer in winter. Another factor is air mass and ocean currents. So how these are responsible? Let's see. The ocean currents also have great influence on the horizontal distribution of temperature. The warm currents increases the temperature while cool currents reduce it in the coastal regions. And if we talk about the wind one, the cold and warm winds also affect the horizontal distribution of temperature. Warm winds increase the temperature, whereas the cold wind reduce it. If we talk about the local aspects as cloud cover, clouds have moderating influence on temperature, producing lower daily maximums and high nights time minimums. In general, the cloudy days are cooler and cloudy nights are warmer. And the other aspect that is known as the nature of the surface. If we talk about the nature of the surface, the earth's surface is covered by land and water. The land surface has different types of rocks. Similarly, the proportion of salinity varies in the ocean. Land surface is general heat up more rapidly and intensely than the water surface. On the other hand, land cools more rapidly when the source of heating is cut off. Students, the distribution of temperature can be understood by two more examples. These are known as the January isotherm and the July isotherms. So what is the difference between these two isotherms? Let's see through the map and the pictures. The July isotherms. Isotherms are more irregular in northern hemisphere and more regular in southern hemisphere. The isotherms are closely spaced in the northern hemisphere. If we talk about the temperature, more than 30 degrees centigrade isotherms passes through northwest Argentina and central Australia in the southern hemisphere. If we talk about the July isotherm, more than 30 degree temperature occurs in the belts between 10 degree and 40 degree altitude. The isotherms bend towards equator on the ocean, towards pole on continents, and vice versa in the southern hemisphere. Isotherms are more regular in northern hemisphere in the July isotherms. Students, as you have seen the isotherms of January and July, both are different due to few factors which already I have discussed with you. These are altitude, latitudes, the distance from the sea areas, and many more factors are there which are affecting to the isotherms as accordingly. Students, normally air temperature decreases with increasing elevation in the troposphere, but under certain weather conditions the converse may be true. Students, as you know, the temperature is maintained through the energy which is received by our solar system and which is revert back. So a few more things are there through which the temperature can be maintained. In that series, one more process is there that is known as the inverting process. So what is the inversion of temperature, that we will see in our this topic, that is known as the inversion of temperature. Or we can say, in the inversion process, the temperature, instead of decreasing, increasing with the increasing of height. As the height is going to be increased, the temperature is also going to be increased instead of decreasing. That is known as the inversion of temperature. In brief, it is an increase of temperature with height which occurs in the lower part of the troposphere. There are total 3 types of inversion, as number 1, a high altitude inversion, number 2, the advective inversion, and number 3 is a ground inversion, or we can say radiative inversion. So with the example we will see the 3 types of inversion. As number 1, a high altitude inversion, it occurs mainly due to the frontal convergence when a warm air mass is forced from the ground surface by the underlying cold air mass at a cold front, then a high altitude inversion is occurred. And if we talk about the advective inversion, which is number 2 inversion, the cooling of warm air which is passing over a cold surface. The persistence inversion may be accompanied by thick fog if the air is moist. And if we talk about a ground inversion or radiative inversion, which is an important type of inversion, a ground inversion is much more localized and is often dependent on the terrains. It frequently occurs during winter anticyclonic weather when during calm cloudless nights there is a rapid heat loss from the ground by radiation. For example, long winter nights, so that long wave radiation results into loss of heat and the ground surface become too cool. And second example, we can take the slow movement of air. If the slow movement of air, so that there is no transfer and mixing of heat in the lower layer of the atmosphere, so it can be caused for a ground inversion. Snow covered surface, slight air movement, clear skies, long nights, these are few examples, or we can say the favorable condition for inversion of temperature. So students, here you have seen what is temperature and what are the factors which are affecting to the temperature distribution, and we have also seen the inversion of the temperature. Students, here the chapter is complete. Hope you understood this. Students, in next video we will study about the atmospheric circulation and the weather condition. But before starting the 10th chapter, we will discuss more about the temperature. So for that, keep watching SST June.